What is up, guys? Welcome to the second episode of Straight to the Kokoro. I'm joined today by Tetsuya Kawakita. So I know Tet from powerlifting originally, and then we honestly found that we had a love for soul food after we got soul food at a meet one time. Tet has a bachelor's in chemistry, currently going for a second bachelor's in chemical engineering. Overall lover of science, gaming, and lifting, which is, like I said, our initial common thread when we met. And then also rom-coms, which I did not expect both of us to love. So welcome to the podcast, Tet. We're really happy to be catching up after it's been a minute.
Thanks for having me, Trevor.
Of course. So I think my opening question, which just off the top of my head earlier, was kind of like, tell me about like a really critical moment in your life and like an anime that you were watching during it, or what it means to you, like how it brings you back to that moment.
Oh wow, that is a hard question.
Yeah.
For a second. Well, let me think. That's really.
It doesn't have to be like a perfect like this peak moment, because we have many peak moments, but like tell me like a defining period in your life, maybe where things were really good, things were really bad, and then like something you just associate from an anime standpoint during that time of your life.
Maybe this is where everyone knows this anime or it's a movie, but A Silent Voice. Have you seen that one?
I did. I actually saw it with
so good.
Saki at an anime convention, and I had no idea what the fuck we were watching.
Oh
man, so sad.
Yeah.
What comes? I mean, I think it's one of the top three. Like, if I had to say three of my favorite anime movies, it's probably A Silent Voice, which I have to rewatch, so that would be three. Your Name, which is two because of the ending.
Oh, that's a great one.
And then Weathering with You, dude, I just thought was like so beautiful. What about you?
Oh man, those three are definitely at my top. Those are crazy good animes. But I think I brought up A Silent Voice was just because it sometimes makes me think of like my belief is that more humans are good than people think. Like, and when you see A Silent Voice, you know, like this girl's deaf, and kids can be really fucking cruel, but it makes me happy, and knowing that like all the people who are kind of cruel to me, when I see them again, they're like grown up now. They're so much nicer, they're so much better, and like just it kind of, what's the word, I guess, agrees with my philosophy that for the most part, humans end up being good to each other. Like they realize like we need to treat each other well for us to move on.
I want to like roll with that for a second, because one, I think that's beautiful and I resonate with that. But before I comment, like, where do you, for you, does that philosophy come from? Like spirituality? Is it a religion? Like what kind of, is that always been your belief about like people as they, I'll say, develop? Because that's how I hear you kind of phrasing it, versus being like baseline human nature. So yeah, go for it.
Let me think. So when did I start believing? I definitely didn't believe that for the longest time. At one point, I was almost nihilistic. Like I was like, a lot of people are bad. Most people are inherently like out for selfish reasons. But then I don't know. Like this is gonna be a little bit weird, but
oh, dude, fucking go for it. Weird,
like,
I live for.
Yeah, evolutionarily, or like people say like what is it? Oh, what's the stereotypical phrase they say for evolution?
Negativity bias?
No, not that complicated. It was survival of the fittest. But like what fits the best for survival in the case of humans ends up being that you have to be as good to each other as possible in order to be able to procreate and things like that. And I was like, well, where do I see that in human in humans, I only see like pretty bad people. But then as time went on, I started noticing more of the positives. So I think yeah, definitely had a certain negativity bias, but then seeing it from an evolutionary context, I kind of was able to push through that and like see all the good that people can do, all the good that people can be. And based off of that, I think that's how I got through that, saw how my philosophy changed and saw how good people can be. Obviously, there can be bad ways to take evolutionary theory, with the obvious one being Hitler and things like that. But yeah.
For sure. I think like off of that, like at least for me at this point. So I think maybe it would be considered a point of nihilism for me too. Like there was a point in my life where I wanted to do everything alone and it was like, fuck everyone else. I'll just like kind of be this lone wolf thing, right? Like, and then a lot of that shifted later as I got more into spirituality, where I agree with you too. I think people do things, people hurt other people because they're simply misguided and not under, there's not clarity there. And like with that, I think like the baseline reason, at least as I really love psychology, and as I've like kind of been exposed to more and more, it's like people hurt each other because they're suffering. Like, but if you have clarity, like if I'm feeling really good, right? Like I'm even more likely to reach out to the people I don't love as personality types, but I don't want to see them like get hit by a bus. Super extreme example, right? But like I don't want to see them in pain, even though I might not care for who they are as a person.
Yeah. There was oh, that reminds me, there was a human psychologist that I was listening on a science podcast. I forget which science podcast, but she talked about, if you think about it, all the people who do terrible things to other people, most of them are not like evil people. Most of them really do regret what they've done to other people. There's no one who's really like 100% this dude's evil. He's just doing it because like this dude's doing it just because he wants to make others suffer. Like it's not, that's very uncommon. Like a lot of times, it's most of the time like something happened in the moment and then they do something and they're like, well, I really wish I didn't do that. I really regret it. And you know.
No, I think that's spot on. I also just think of like trauma people have experienced like in their past, which distorts their ability to make the more moral decision, I'll phrase it as, rather than like the right decision.
Yeah.
But yeah, I definitely agree with that. I think it's far healthier too to move through the world like with that like the perspective we're talking about, versus kind of thinking like everyone's out to get you, which like one, you're never going to feel safe. Two, it's like it's going to fuck up your ability to connect with people. And I feel like yeah, I just feel like that comes back, I think, up to so many animes where you see like, you ever see I Want to Eat Your Pancreas?
I just saw that the other day.
Okay, what were your thoughts before I asked this question?
Oh, or like that dude who's like, I really love the anime where it's like this dude who's a loner and like hates other people.
Yep.
Gets helped like, or gets help breaking out of his shell by someone else. I love things like that. Like it reminded me really similarly to the general plot of Your Name.
Okay.
Or not your name, sorry. Oh, why did I say that? Your Line, April. That's
I haven't seen that one yet. I think you're the second person that's told me in the last like week about that one.
okay. I won't say too much about it, but oh, it's so good. But yeah, I Want to Eat Your Pancreas. Like the girl, she's like so pure and like no matter how much he pushes her away, she like tries helping, like is helping him break out of his shell. And then oh, the ending, bro.
Oh, dude, yeah. For anyone that's listening, you need to watch it. The ending is like, I did not see that coming. Like that's the only thing I'll say. It's like I didn't see it coming, but I think like you said so well. Like even that's like you have this person that's like super closed off to the world and hasn't had these experiences or feels like a loner. And then like you have that character who's at the polar end, the polar opposite, generally like that super popular, good looking. I don't know how you define that relative in anime because I feel like they don't draw most people like in a really
Yeah.
in a really distorted, disturbing way, unless it's like a different genre.
Yeah.
But like, yeah, I think of even like My Dress Up Darling has that kind of feel to it.
Oh yeah.
I don't know if you'd even argue Buddy Girl Senpai to some degree does. Like my
I
is
would actually say yes.
to a lesser degree, I feel like, but there's still elements of it there.
There's elements of it, but they're trying to not like break them at like a shell of what is it being? What's the word? Unsocial, but more so just getting over your personal um issues and being able to move on. You know, it's a coming of age kind of thing with Bunny Girl Senpai.
Yeah, I definitely did think it was really interesting that they did like adolescent syndrome and the whole
Yeah.
like the atmosphere kind of thing. And for anyone that doesn't know, it's talking about like I guess like a social environment, both like in a school setting, and then it obviously extends to like the general city. And I guess you could argue if you go to the country and then you have the world, like the
Yeah.
social climate, I guess to some degree.
Yeah. Yeah. Like
But
I can actually relate to something like that because my girlfriend now, she helped me become a lot less serious about everything and be able to joke around a lot more. Like we talked about it before, like the shit talking kind of like relationships, they're so great. When I walked into it, I was nothing like that. I was much more serious and things like that. But with her, she helped me get out of that. She helped me be able to joke around more. And definitely that's led my life toward a more positive direction, we'll say.
very cool. Do you feel like there's anything on the other side that you feel like you've helped her open up to on her side of like understanding herself better, or maybe changing herself in a positive way that's like helped her grow? Because that's like a big deal, obviously, to be able to like joke about stuff that you're always just like no serious all the time. Like
Yeah. Like she, when I started dating her, she was 8. No, hold on. Let me do the math on this. She was about 19. Um, um,
all good.
yeah, she was about 18 going into 19. And she came from a string of bad relationships. And it had her come out with many trust issues, admittedly. So there was the lowest point in our relationship, which was early on, was I needed a job. After a chemistry degree, I could not find anything. It was not going well. And I was like, well, I need something. So I started doing personal training because at New Paltz, I did get a certification, AFA certification in personal training. And she looks back and thinks, what was I thinking at the now? But she would start arguing with me because her trust issues, she thought I would just be a personal trainer, flirt with girls at the gym and like cheat on her and stuff. And that was I told her, look, you have to trust me. You have to learn to trust me, or else this just isn't going to work out and we're breaking up. And like, because of that, she was able to get over her trust issues. Like, obviously not instantaneously, but she learned to trust me. She learned to grow, be more of an adult, be trusting of others again. And that's one thing that she definitely benefited from our relationship. Just being able to trust people again, I guess. Yeah.
No, I mean, I know people who have been in that situation too before, where it's like they're constantly on guard because of past negative experiences, and I can only imagine like that's not an easy conversation to have, obviously, and to bring that up. And then for her on that side, like she has to, it sounds like she obviously did, like own her own stuff, so to speak, that it's like this isn't a you thing. You're just doing your job as a personal trainer. It's like her insecurity, which is understandable based on like those past relationships.
Yeah.
I feel like I'm trying to think like based on how long have you guys been together now? That was what I was thinking.
When I officially asked her to be my girlfriend, that's 3 years.
Okay, very cool, man. Nice. Because
Since I met her, it was 4 years, but then
okay,
we
so
needed to make things official when I finally saw her in the Philippines, like met her in the Philippines.
okay, and then how did you guys end up meeting initially?
I was in Japan,
Okay,
and before going to Japan, I wouldn't say a breakup because it wasn't an official relationship, like we didn't officially
yeah,
but I was seeing someone and she broke it off. Like we should just be friends, and I fucking hated that. Oh, obviously. So I was like, before leaving the Philippines, or leaving to Japan, I was gonna just go for a PR deadlift, but like on a deadlift bar bullshit bumper plates
yeah,
them
just fucking send it.
calibrate at the end. And I pulled 600 doing that, which at the
Yeah.
time my best was 540. Obviously, like, but anyway, I posted that in a Filipino like powerlifting group that my friends invited me into, and it was run by my current girlfriend's brother,
Okay.
and that's how and my friends who invited me into that group, they're friends with him, and like that's why or I don't know why they invited me into it, but then I posted it in there. She saw it and she friended and followed me, and then I just started talking to her while I was in Japan.
Very cool. So like a small world type of thing where it's like, I don't know how I got here, but this just ended up happening.
Yeah, it's great. I love it.
Very cool, man. I mean, hey, listen, I'm all for like the deadlift bar and sending it. I haven't done that in a while, but like 600 for me has still always been a goal. Like 585, done it on like a regular situation. And then I'm just like, fuck, like so close, so fucking close.
Dude, every 100 barrier is the hardest to get through.
I think one of the funniest things in lifting and like what it felt like for me was like I got to a 315 deadlift pretty fast. It was fucking terrible. I looked like a cat. But like as I hit like 405, it was pretty fast. And I just remember thinking of like I could pick up like a fifth of a car. And then like after I got to 500, I was like, okay, this is getting kind of ridiculous. Like, is there anything like this is fun, but like what's the purpose of doing this besides my enjoyment, which was enough. But like at 585, I'm like, okay, this is like a fourth of a Honda Civic. Like you're just using other objects to equate your. At least for me, I was like using external things.
Doing
Like I
that
could
too.
pick up like
Yeah.
this many things. But for anyone listening and anyone that has had to move furniture for people because you do a lot of lifting or powerlifting or strength sport, like it's not the fucking same thing. A refrigerator does not have the physics of a barbell.
Oh, definitely not. Yep.
But
Yep.
people seem to think that. At least that's
Yeah.
been my experience. Is like you're strong. You can help me move this pool table. It's like no, I cannot.
Yeah, you definitely once you get stronger, you start visiting other people's houses. You start getting much more invitations when they need to move things.
I felt that I had a little bit of that when we had like initial lockdown, and I had the gym in my house when I was living back in New Jersey. People like, hey, like you want to train sometime? And it's like I live at home, so if I live by myself, it'd be a little different. But like my parents, obviously too, and the whole COVID thing. So I'm like, I'm not having random people over, but people were just like, hey, like you want to train? And it was like, yes, but no, like because like we're in a pandemic and at the peak of that pandemic, but like I just remember that being one of those things, or people just wanted to buy equipment. You couldn't get any like lifting equipment.
Yeah.
I feel like
but
I was gonna say, like, what do you I'm trying to think? Did you have anything else on what we were just talking about, Tip?
not really. Yeah, no, not really.
Okay. I guess like go back to anime and then like, or if you have any questions, we could always like complete tangent. I could care less. Like what are you watching right now and enjoying?
Right now, I'm watching a bunch of stuff. More rom-coms like Love After World Domination.
Okay.
It's a
I've
good
seen that one.
Then there's some isekai ones like everyone calls it Skeleton Knight. I forget the full
Oh,
name.
Skull Knight in another world.
Oh yeah,
Dude,
I
I
love it.
literally just recommended this like the first scene, if anyone watches this, is a bit etchier than I was expecting.
Me
But
too. Me
the
too.
main character is really fucking funny. Like, especially
It's
if you
so
like
good.
gaming, I think.
Yeah, yeah, definitely, definitely. Um, Waiting on Rent a Girlfriend next, and then what else am I watching? I think that's mostly it. Oh, and Shikimori is just not cute.
Yeah, I've
So
seen
that,
the first
okay.
episode.
Yeah.
Actually, as we're talking about this, I think of like my one friend and a lifter I coach. She calls it like Love is War Science Edition, but it's like science fell in love, so we had to prove it.
Mhm.
Have you heard of that?
What is it called?
I think it's like science fell in love, so they had to prove it. So it's literally like, to give you a really rough synopsis, these two scientists who are like overly analytical, and like we were kind of talking about with relationships, they can't joke about something they do. So they literally like have feelings for each other. He's like, how can you prove this like mathematically or like factually? And they just start like testing things like each other's heart rate while in proximity to each other and all these other ridiculous things.
I gotta watch it.
It's really funny. It's really cute in its own way too.
Yeah.
Um,
Well, they have like some of Einstein's field equations.
oh,
I'm looking at the poster now. They have like some tensors in here. Wow, that's yeah.
it literally reminds me of
Gotta watch it.
like, if anyone's also seen or heard of like Dr. Stone, like I actually learned, like they actually talk about statistical equations in this science fell in
Yeah.
love, so they had to prove it. And like I think what deviations are to some degree. I don't remember what the exact term is because it's not deviations, but it's like these different samples of experiments and what you'd expect to see from like how you'd use that to make decisions. But like Dr. Stone, like as both a comedy action, I guess I don't really know. It's not, I don't know what you consider it overall. But like you actually learn chemistry through it. Like,
Yeah. There's
which
a lot of solid science and stuff like that.
I kind of enjoy it because it's just novel in its way, and they've done
Yeah.
it. They've just integrated it in such a way where it's actually still like funny. Like everyone's amazed he figured out how to boil water with all these things or create steel.
Yeah.
I think like I guess off of that, what I feel like we could talk about is like what science we see in like Bunny Girl Senpai. Because when I watched it, there's like a lot of like there's the Schrodinger's cat stuff. There's consciousness from the standpoint like if no one observes it, something's not real. So if you want to like riff on that, we'll just
Oh,
go
definitely.
there.
Yeah. I will say one caveat I'll make at the get-go is a lot of my knowledge of quantum mechanics is definitely at an enthusiast level, although I have done some quantum mechanics calculations for chemistry. For those who are interested in taking chemistry, you do have to learn quantum mechanics in this class called physical chemistry, where you do, and it's like 75% quantum physics, and you apply that to chemistry in the last quarter typically in these absurdly large matrices, which are linear equations you put into basically this interesting looking box to do calculations. But admittedly, in Bunny Girl Senpai, they don't use quantum mechanics to accurately like talk about talk about the physical world, but they use it more so as metaphorical in what they're doing in the or how the story's going. So one of the things they talk about Schrodinger's cat. So Erwin Schrodinger, he actually made that thought experiment to try to make fun of quantum mechanics, show how absurd it is, because in quantum mechanics there's this concept called superposition, where a quantum particle, photon, electron, things like that, is both can be a wave and a particle at the same time and be a different mix of those two, whether it be 10% wave, 90% particle, or 50-50 and things like that. And Schrodinger, or modern day, what all you hear about quantum mechanics is this version called the Copenhagen interpretation, which there's other theories that try to fight it. One of them is called pilot wave theory or Bohemian mechanics, and others called hidden variables, which Einstein was a fan of. And then the other is the many worlds, which you've probably heard that, although people misunderstand the many worlds theory and thinking that every time you have to make a decision, the world splits, and that's completely incorrect according to the proper theory. The proper theory is when a wave function collapses, where so one of these like quantum not particles, quantum waves collapses from its superposition, the world splits. So what that means is like when when the wave function collapses, either the particle becomes a particle, or the quantum object becomes a wave or a particle. In one world, it's a wave. In another world, it's a particle. I'm admittedly not a big fan of it, although at the same time, it's probably because I don't understand it to its fullest extent. But it's like unfalsifiable things like that. But anyway, going back, Schrodinger wanted to mock the concept of basically the Copenhagen interpretation, because he was like, nothing can be both a wave and a particle at the same time. That's ridiculous. Obviously, like this cat in this box is dead. You pumped radioactive material in there to kill it. But obviously, that's stuck in a way he didn't want it to. And yeah, but there are other concepts they talked about in there was like Schrodinger's cat, or not Schrodinger's cat, Laplace's demon.
Yeah.
Yeah, that one, it's not as much quantum mechanical, but you remember the Laplace's demon, where it's if there was a demon who could understand what every single particle in the known universe is doing at that moment, you could predict the future and things like that. That another interesting thought experiment. Yeah, I'm surprised they didn't. This would have been really cool if they talked about it, called the delayed quantum erasure experiment.
Eraser?
Yeah.
Okay, cool. Just want to make sure I heard you right.
So that led to this thought of, or it's very closely linked to thought experiment by Richard Feynman, who's a Nobel Prize winning physicist, called the One Electron Universe. I think it's what it's called. But the original experiment, it leads from what's called the double slit experiment, which is a famous one, where what they did was they were shooting electrons through two slits. And typically, if it's a particle, once you shoot it through two slits, you'd expect, or on the other side, or two slits, you'd expect on the other side to create just two slits as well. But if you push a wave, like a water wave, through two slits, you're gonna notice that the waves kind of stack like this, and you create what's called an interference pattern, where you see if you kind of map the peaks of these waves and their strengths, you notice that you get a strong line in the middle, weaker lines here, and slowly more and more weaker lines. And that's called an interference pattern, because they interfere with each other.
Is it kind of like the shape of a bell curve, like the highest peak is in the center, and then as you go towards the outsides, it's kind of tapering down?
Sort of, if you think of like a really bumpy bell curve where it's like,
so it's constant dips, like peaks and valleys.
Yeah.
Okay.
So when they were shooting electrons through, because they thought an electron was a particle at the time, you'd expect just the double slit pattern, but they were getting a wave interference pattern. And they were like, oh, what's going on here? And so what they thought was, oh, maybe the electrons are banging against each other and causing this weird pattern. So they started shooting one electron through at a time, and they were still getting the wave pattern. And they're like, so the electron is interfering with itself? What? So that's really weird, right? Because you'd think you shoot one electron, it goes through one slit and then just comes out on the other side there. But no, it was creating a wave pattern, even though they were shooting one at a time. So then they were like, well, let's put a detector somewhere so that we can measure which slit the electron goes through. So they did that. And then while they were shooting the individual electrons, created a double slit pattern instead of the wave interference pattern, which so their reaction is, oh, so the electron wants to be a particle now? Are you kidding me? And people misunderstand that this means, oh, the electron knows that we're watching it. That's not true.
Okay.
People miss.
Oh, you froze for a sec, Ted. Crap. Did I lose you?
Oh, there, we're good. We're good.
Yep,
My
we're good,
screen
we're
just
good.
froze for a second. But people misunderstand what that means. It might be my internet. Sometimes my internet.
All good. I was just like, actually, no, sometimes this computer messes up. So I was like, this fucking thing just lose Wi-Fi.
But so yeah, people misunderstand that to be like the electron, the quantum mechanical particle knows. No, it's just a thing of our previous methods of measuring things. We would shine light on things. We would shoot, obviously in this case, you wouldn't shoot electrons at it, but we'd shoot electrons at it and then like measure where the electrons are bouncing off of to create an image. We do all these things. But at a quantum mechanical level, the methods we use to observe these things interact with these particles because they're so small. So before, a photon bouncing off of, let's say, I don't know, an amoeba you're looking at under the microscope, the amoeba is not going to react, it's light. When you're looking at a tiny electron, which is in the quantum mechanical realm, that photon now has actual influence on it because you're at that small level. So because of that, you trying to observe it using light or whatever method you're using, it interacts with the system, causes that wave function to collapse. That's why, like, when they were trying to measure which slit the electron was going through, they were interacting with the system. So the wave function collapsed, the electron became a particle.
So if I'm going to say this right, like, so it technically, when I hear that, I think it does change in the presence of an observer, because an observer is adding like an additional input of light. Like if you weren't adding the light, the electron would have nothing to react to. So it's not
Exactly.
It's not untrue. Like it is true, but it's not maybe true for the reasons people think it is.
Yeah, exactly.
Like they're thinking it's merely like our presence, which in some part it is, but it's really the light reacting, the photon reacting with the electron that's causing that.
Exactly. So it's a
That
good
makes
analogy that I've heard was when you drop something in between your car seats and you try to put your hand in and try to grab it, it falls down further. It's your mate. If you don't touch it, it stays there, but obviously you need to get out. So you put your hand in and it falls down. You're interacting with the system, you're causing it to change. But taking it back to the delayed quantum erasure experiment, what they tried to do is they tried to do sort of a dual double slit experiment, except they do one close and one afar, and they shoot a beam of light to split it into two different directions. And it should, because the speed of light is infinite, it should interact differently with the closer double slits compared to the further double slits if they try to observe one of them but not the other. According to the double slit experiment, one should be a wave, one should show two slits like particles. So what they did was they put they put detectors on the further one so that it should create a particle-like pattern. And you'd expect, since the detector's interacting all the way at the end over there, and it shouldn't influence the closer slits, where so you should see a wave pattern in the closer slits and a particle-like pattern in further slits, right? So what they did was they tried it, and they ended up getting particle patterns on both, even though the closer or the further double slits, the detector is all the way over there. The photon should be interacting with that after the first double slit has taken place. So it's almost like these particles went back in time to tell these other particles, hey, they're watching us act like particles, which is crazy. So
Yeah, don't do that.
yeah. So one thought process, or one not thought process, but not a thought experiment, that's what I was trying to say, by Feynman was based on that. Let's say that we had a one electron universe, but this electron, because like we were getting this weird thing of like time travel, basically, like photons telling previous photons, hey, act like a particle. He said, well, can these particles go through time? And Richard Feynman thought maybe all the electrons in the known universe is actually just one electron going through time, taking the spot of all the other electrons that we seem to observe. And well, yeah, that one is just interesting because for people who don't know, electrons do everything in our material world, basically. For those who took high school chemistry, all the bonding is due to the sharing or transfer of electrons. Without that, we wouldn't have actual materials to make because they wouldn't stay together. And yeah, chemistry, well, is the science of the electron. That's one way people interpret it, because you're looking at all these things that are caused by the electron. Bonding is caused by the electron. Color is caused by the electron. Everything like that. And well, going back to quantum mechanics, people used to think it was just a particle, but in reality, it's this, or I'll put air quotes on reality based on the Copenhagen interpretation. It's this really odd quantum mechanical object that can be both a wave and a particle at the same time. Yeah.
So okay, so it's like it doesn't have a fixed identity in quantum mechanics. Like an electron doesn't have a fixed identity in quantum mechanics. It could be either or depending on the situation.
Yeah.
Okay.
So interesting how that works. Yeah.
So isn't, to go back to like Schrodinger's cat, isn't that kind of the whole thing? Like the cat is either alive or isn't. And in theory, like you said, right? Like I know from what I've heard, he like on a timer, it was like statistically chanced that radioactive gas, I think, would be pumped into the box, right?
Yeah.
But like until you open the box and observe the cat, which means you added input to it to some degree, like you don't know. And I think like, yeah, I think, I don't know. I just think like different things. Like for you, what you might really enjoy is there's a book called Biocentrism.
Okay.
And it's kind of on, it's on consciousness to some degree. Like these two dudes who are, I feel like they're PhDs in physics. They're not neuroscientists. And like they both take in meditation, are kind of having the conversation of like, you know, is it the chicken or the egg? Like, is it consciousness and then like the world kind of happening, if I'm not misrepresenting this book from when I listened to it. But it's talking about how like things change. Like we need someone to witness something for it to exist. So if you wanted to go like, does a tree fall in the forest? Like, was anyone there to see the tree? Because then it's like, what tree? Like,
yeah, I see that. That's really meta. Yeah,
it's a really interesting book. Like I listened to it on Audible and it was actually read really well. But it's definitely not one of those things. If you're like, you might confuse yourself, like I do at times. But it was definitely really cool to hear from a science perspective exactly what we just talked about, where it's like in the presence of an observer, an electron behaves differently and atoms behave differently. And then if you were to just leave them on their own. And what you said makes a lot of sense. You're adding some kind of input to the witnessing of it, even if they're not conscious like on superficially if someone wasn't conscious of what they're adding.
Yeah. Oh, that stuff is so cool. I love it. But yeah,
Dude.
and like when you hear all this cool stuff, it's really interesting when you learn it in school. I mean, I love math, so it wasn't dry, but compared to me, other than me, it's the driest subject you can possibly do. It's so much just differential equations and mathematics. And another thing people don't know much about quantum mechanics is it's a amazingly new thought process to physics, because typical physics like Newtonian physics or general relativity is deterministic. You can measure these things. You can just be like, oh, what's the speed of this thing? You measure it. Quantum mechanics was not deterministic at all. It's actually probabilistic. It's all about different probabilities. Like within this, like let's say you have a box and nothing can get out of it. You put in one quantum particle. What's the probability that it'll be in the first half of the box? And and you calculate the probability that way. What's the probability that it'll be outside the box? Now, I just told you, oh, nothing can get out of the box. Quantum mechanics, that's not true. There is a small probability that the particle will be outside of the box, even though I just told you that it can't get out, because of a concept called quantum tunneling, where it turns into a wave and it can actually go through the boundaries.
What would cause it to turn into like what's needed for it to become a wave in that situation?
Or it's just the probability of it being a wave because of its wave function collapsing. So it was in a superposition before, and then every now and then it decides particle wave. So it'll at one point just become a wave and then pass through it. It's not you pushing it. It's its own like natural physical property that it'll just be a wave now and then.
Okay,
just go through the boundaries.
So is it just the like at the right moment as it's moving positions in this box, like if it happens to get to the edge of whatever corner part and it's a wave at that moment, it can pass through the box?
Yeah.
Okay.
And
makes
by chance, have you listened to like Andrew Huberman, his podcast?
I do know who he is. Yeah.
He talks about how important it is to get sunlight at the start of the day. Yeah, you heard about that? And like, you might think like, oh, there's a window here. I'm getting a lot of sunlight through it. It's shining upon my face. I'm getting it enough. But Andrew Huberman said, no, the window blocks more than you think. You actually need to get outside, get that sunlight. And there's actually a good reason why. You might be getting what seems like a lot of light, but the light that passes through your window isn't actually like the photons can make it through so easily. It's actually due to quantum tunneling. The light coming through, because if it was in a particle form, it gets caught up into the atoms that the glass is made out of. But when it's in its waveform, it can pass through. There's also probably some emission due to excitation of the atoms, but that's a different thing altogether. But because it's due to quantum tunneling, remember that the particle being outside of those boundaries is a low probability. So obviously, even though it's a low probability, a lot of photons are shining in, there's going to be some that makes it through. The window blocks a lot of light, way more than people think, because of the quantum tunneling effect. That's why, in order to get the sunlight you need to wake you up for the morning, you do need to step outside. So there's no boundaries trying to block it from you.
That makes a lot of sense, actually. Like, I would have never thought about that, but you're saying, because it has to be a wave, right, to be able to move through the glass. And that reminds me of the dude who actually I reach out to for like nutritional advice. His name's Andy Triana. I feel like he's again a person that's like a Swiss Army knife of skills and tools, but like he's mainly in the fitness realm and nutrition realm. But he told me the same thing you said. So there are different waves that the sun, different like spectrums maybe of light, or different types of light throughout the day. So like there's like moonrise, moonfall, sunrise, sunset, like, and that's all different stuff that our system can take in. So he actually gave me that advice that you gave me, which is like for the purpose of my circadian rhythm, like upon waking up, I want to have some kind of sunlight exposure. Same thing before going to sleep. I need to get some kind of moonlight exposure because it's going to tell my system like, hey, it's time to like turn the volume down, get ready to transition to sleep.
Yeah. Like the different, depending on the day, all the time you're getting different wavelengths of light. And so this is where like kind of color comes in, because the color you see, they're all light, but they're different wavelengths. The more blue you get, the higher energy photons they are. So the wavelength is shorter. While the more red side, the wavelengths are longer, they're lower energy. So like during the sunset, when everything turns more red, you're getting longer wavelengths of light, you're lower energy wavelengths of light. Now someone might interpret that as, oh, low energy, go to sleep. I'm not going to step into that, but I sort of forgot where I was going with this, but yeah, different wavelengths of light lead to different colors. Possibly your body or your circadian rhythm, your brain and whatnot, they'll determine what time of day it is based on the wavelength of light that comes into your eyes. But yeah, and another thing, this is going to be a different segue. People who say things like 5G is bad for you. I know it's a very niche thing that people say, like, oh, 4G is bad, whatnot. Like, people don't understand. These are in either the microwave or the infrared range of light, or the radio wave range, where these wavelengths are very long. They're much longer than the visible light. The light that you see getting shown on you is higher energy than 4G, than 5G, than infrared, all these things. You're emitting infrared rays all the time. So when people say things like 5G causes cancer, absurd. When people say, oh, don't keep your phone by your head too long, it'll cause brain cancer, again, absurd. And one of the things that they say is like 5G can interrupt birds, like, so birds follow birds, when they migrate, they're affected by Earth's magnetic field. People say like, oh, 5G disrupts that for birds and ends up making them go in different directions and causes that their process to be disrupted. And they found that's not true at all. But what's interesting is radio waves, so even lower wavelengths of light that we can't visually see. Those actually disrupt birds' flight paths, but not 5G and higher wavelength light like that.
I wonder if that's because of like just their ability to perceive sound, and like a radio wave, obviously, like maybe we can't hear it, right? But like, can a bird have the sensitivity that it can hear it? But even if it can't, like unconsciously, there are all those things that we as people pick up on, like that, we can't express, like, I'm really feeling actually we can express, right? Like, I'm really feeling the atmosphere of the room. And despite it's not like a visible thing in the sense of like, you could energetically see it, like you could still feel that there's this charge to an environment.
Yeah, I won't lie, I have no idea, but I don't know why that's the case, but yeah. It's
like why we feel that, or you're saying like
why we feel that, and also with the birds, why it radio waves affect them, but higher energy light doesn't affect them. I have no idea.
I don't know. Yeah, that would be very interesting to know because they have pretty good, from what I know, like most birds have really good vision. Like it's not like a shark that it's like basically blind. Like their sharks have fucking terrible eyesight.
Yeah.
So yeah, I'd be curious how that like interferes with their sense of navigation, I guess, and how they're moving through the world.
Yeah.
I think
And
for us, probably the simplest thing I can think of with like being able to read the room is it's like a nervous system thing. Like
yeah.
you could feel if you're in like I don't know, they put me and you in like downtown Baltimore, I think, which I think is a pretty bad place to be. Like you're gonna feel unsafe depending on where, also depending on relatively where we grew up, right? So if we grew up in like a country that's like overtaken with war, you put us in like, I don't know, Dakota or something. I'm assuming like someplace there's like not really stuff going on. Like we'll be okay. It might actually be alarming that there's so little stimulus. But like if you put us in New York, maybe it's like we're calmed down because it's not as high intensity relative to what we're used to environmentally, but it's still like fast paced enough. I think if you're going to either end of any extreme, you can disrupt someone heavily just because it's so novel compared to what they normally experience.
Oh, definitely. Yeah.
But oh, that's very cool, man. I did not know that electrons are like they're a quantum object, you said, right?
Yeah.
Okay, yeah, I would have thought of them as just being a particle, especially like before you saying that they could exist as both is really interesting. And I guess that makes sense with the Schrodinger's cat thing too.
Yeah.
Is like
It's
it's one or the other.
there. It is really interesting. Like the standard model, which is what it's like. If you Google the standard model, you'll see like a table of various quantum particles. So protons and neutrons are not quantum. They are subatomic, but they're not quantum per se. The main ones are like the W and Z bosons, which those are the quantum particles that are responsible for what's called the weak nuclear force, which is what causes basically radioactive decay. There's
Okay.
then there's the gluon, which it's interesting what the gluon is. So there's you've probably heard of quarks. Up,
Yeah, I've heard of
down.
quarks and even like bosons, like you just said, but never gluons.
Yeah, gluons are
Got
what's
nothing.
responsible for what's called the strong nuclear force. The name makes a lot of sense when I explain it. So um, basically, these protons and neutrons are made of up and down quarks. I think it was the proton is 2 up quarks and 1 down quark, where these quarks have fractional charges. I believe it was an up quark is 2/3 a positive charge. A down quark is 2/3 a negative charge. No, I think it might have been a third. I think it's a third of a negative charge. Yeah. So a proton is made out of 2 up quarks. So you have 2/3 of a positive charge each. So 4/3, and then 1 down quark. So a negative third of a charge. So overall becomes 3/3, or
Okay, so it's one
charge.
Okay.
Well, a neutron, it has a neutral charge, 2 down quarks, so -1/3, -1/3, -2/3, and 1 up quark, so it's positive 2/3. So those balance out. So that's why the neutron is neutrally charged. What's the particle that keeps those 3 quarks together? That's called the gluon. It's the glue that sticks them together. That's why it's called the gluon.
Damn.
So
That's
yeah, it's
crazy. No, that's crazy. It's always amazing to me how many more layers there are under everything that you would just never, I would never think at times, where it's like it comes the same way in like biomechanics, where it's like, oh, like your muscle attaches to bone, and it's like, okay, well, muscle, like at least they've talked about really recently more so, like everything is 3-dimensional and like transverse. So like a muscle, even like your bicep, isn't doing like this straight line of pull. It's actually like coiling as it contracts from like end to end, which makes a lot more sense, right? Like
yeah,
otherwise we'd be like stickman anatomy.
yeah, huh. That is interesting. Well,
And yeah, and I know something my boss Connor said is like as above, so below. So if you look at muscles and then you go into like the more fine aspects of like what composes a muscle, like they're also these coiling structures, and the most efficient shape in, I think, life is like a triangle. And if you stack enough triangles, you end up with a helix, which is what DNA is. So like everything is like just layers of that. Like I'm pretty sure bone has that pattern too, like that Eiffel Tower-ish looking representation.
Yeah, that's actually leads into like biochemistry, which I mean, I won't lie, I hated biochemistry, but um, there are these primary, secondary, tertiary structures, and you notice that it's just coils of things. So now, if I try to go into it, I'm gonna destroy it. So I won't get too far into it.
Okay.
You end up with these coil. This is an actual term they use, coiled coils. So you have coils of these smaller structures that gets coiled into
Yep.
these more larger structures, these secondary and tertiary structures, and your bone, which is mostly collagen. Your body is mostly collagen in general. Is that those are, or it's a protein, but it's those amino acids, they get coiled along, and then to make these proteins they also get coiled upon each other. And yeah, that I like that. As a, what is it, as above so below, he said.
Yeah,
that makes a lot of sense. Yeah,
that's
that's
what Connor
interesting.
said. And I forget where it comes from. I think it's somewhere like Greek, like one of the great like early people. I don't know if it's like Socrates, Aristotle, like it's that realm of people. I don't think like a philosophers, so to speak. It's just like we see these repetitive patterns, like spirals, even in like seashells. You have aspects of trees. I think like just nature's pattern, so to speak.
And I won't lie, with spirals, a lot of people think about the golden ratio. Hot take: golden ratio is overrated. There's more things that don't follow the golden ratio than do. But
what is the golden ratio again? I've heard of it, but off the top of my head, I can't really tell you what it is.
the golden ratio comes up when looking at the Fibonacci sequence. But to put it simply, when you think about like a seashell,
Yeah.
and let's say, I'm going to butcher this explanation, but there's a ratio at which it's really bad. The ratio at which the seashell basically gets larger from the inner spiral.
Yeah.
And you can draw these lines. That ratio where it gets bigger each time is like the golden ratio.
Okay. Is it like it's proportional, I'm assuming, or something like that?
Yeah.
Okay. That makes sense. I'd have to look into it too, but yeah, I know what it is. I'm not familiar enough to describe it.
Yeah, but hot take, it's overrated. There's other things that are more interesting, I should say. Like this is a weird one. You've probably heard of it's called Euler's number. Let me just
I have not actually.
It's just E. Remember learning in math the number E. So Euler's constant, or Euler's number.
Okay.
So that's like pi, where it goes on forever.
Yep.
That number is interesting. It came up it just popped out when people were playing with the math, and it ends up applying to the real world everywhere. That one's much more interesting.
Euler's number. Okay.
Because the first person to really kind of discover it was a German mathematician who was playing around with the compound interest equation, which it's, for those who don't know, its amount is equal to principal times 1 plus the fraction, where the numerator, or the number on top, is the rate, and the denominator is the number of times it's compounded per year. The 1 plus that piece taken to the power of n, which is the number of times it's compounded per year, times time, the amount of time you're considering. And what you do is you assume that you have a 100% rate. It's compounded once a year, or No. You increase the number of times it's compounded within a certain time frame
Yeah.
within a year. And basically, the more, and you're going to notice the more times you compound it within a time frame, you get more, you get a better number.
Yeah.
So if it's compounded once, 1 plus 1, 2 to the power of 1 times 1. So you end up getting 2 times your principal amount. You compound it twice a year, you end up getting 2.25. And then it gets better and better, but over time it slows down. Once you start infinitely compounding it within a year, you end up with Euler's constant, which is E, which was 2.718 something, something, something.
Okay.
So that one, it's weird because you're just messing with equations you made and you end up getting this number, but it appears everywhere. For example, one of the things I was doing was I was interning at a drinking water treatment plant last year, and I was trying to create a mathematical model that simply put tried to model the rate at which we were cleaning our filters compared to how much the filter material was wearing. That model ended up not really working. It ended up being more of a model of how clean the filter got compared to how fast you're pushing the water through, which logically that makes sense. But excuse me. But I was trying out different power models, so 2 to the power of something, all these kinds of things. And I tried, and like they wouldn't fit well compared to the data I was collecting. They weren't fitting really well, which how I was collecting the data. I was just collecting the water as it was being cleaned. And over time, you see it's like really dirty at first, and then it gets cleaned over time. But I was doing that, and there was only one model that fit really well. And that was E to the power of, well, all this complicated stuff. That's the only model that fit well.
And
it harkened back to how fascinating this number, E, this transcendental number, how it appears everywhere in the world, because all these other stuff wasn't working, but only E was working.
And that was Euler's number again, right?
Yeah, which just came out of just playing around with math, which is a human-made concept.
I mean, I think of part of that just reminds me of like the compounding interest equation. Like if you're talking about like, we're just going to talk about money, right? Like the more times it can compound, the higher the number is going to be. And you have a very, off the top of my head, similar equation, like the number of times it's compounding a year, like n times t is the exponent, so to speak, of like whatever the amount is or the principal amount is.
Yeah. So the continuous interest equation?
Not off the top of my head, but I know exactly. It's like, it's like n divided by whatever times whatever or something like that. I don't remember off the top of my head, but I know what it is.
So E actually is in that equation, because in the compound interest equation, you infinitely compound it. That term, the 1 plus r over n, that collapses into E. So it ends up being principal times E to the power of nt, something like that.
Okay.
But yeah, it's that's how the continuous interest equation kind of pops out. You compound it infinitely, collapse into E. And yeah.
That's crazy, man.
It's so interesting. I love math. Yeah.
I feel like there's so much there. I feel like I was thinking of Steins Gate at one point. I feel like it's something you would enjoy as a person. I haven't seen.
Never watched it.
Neither. I watched one episode, and I got to go back to it because the opening is good enough that I'll give it another chance.
All right.
Trying to think. I guess like closing it out. Like if you want to be found and if people want to connect with you, or even like game with you if you're open to that, what's the best way for people to kind of locate you?
I would guess just shoot me a DM on Insta. So my Insta, I haven't posted a lot lately, but it's Quadzimodo, QUADSI period MODO on Instagram. And yeah, that's the best way to reach out to me if they want to on a game with me, talk about stuff. And yeah, That's it.
Cool. Well, this was definitely, I was not expecting us to go in those kind of directions or even have this kind of conversation. So that was really cool. I also definitely, that makes the electron thing makes so much more sense to me relative to other stuff I knew, even in that biocentrism book, when they talk about like the behavior of particles as you're observing them.
Mhm.
So I think off the top of my head, we'll end this with like, there's one anime you could recommend to anyone off the top of your head. Doesn't, you can always have like a second choice later on. Like at this moment, what would it be? If you're just like, someone came up to you and is like, you know what, I can make that more refined because I think that's too broad. If someone's like, I've never seen anime before, they're a bit averse to it. So like they're thinking of like octopus tentacles because for some reason that hentai is grouped in there. Like what would be the starter anime you would recommend to someone off the street and why?
Man.
Or a starter anime.
Let's see. If you're looking for like a real depth, like seeing like all the messaging behind it, I might say this is very common for people to recommend this, but Full Metal Alchemist Brotherhood.
So that was actually in my head as I was thinking about it just now. I wasn't sure if you were going to go Death Note, and I was like, I feel like that's another generic one, but I think Full Metal is like, it is on the one website like the highest anime period like of all time.
Oh yeah,
Brotherhood. Don't watch the original. Don't.
Yeah, no, don't watch the original. But like, yeah, why I love it, or it's just obviously the story's great, but the messaging behind it. It's not just like I want to tell a story. It's like I want to tell a story and make social commentary on the real world, and that's what's so good about it.
Cool. Well, I think that's a beautiful recommendation. That would be up there for me too, especially like I said, if someone's like averse to it, because I think like we can obviously talk about etchier shit, but like someone's gonna be like, is this like don't watch Food Wars off the bat, unless you're really into that kind of stuff. But do your research. But cool. Well, thank you, Tet. It's been an absolute pleasure and super engaging and fun.
It's been great seeing you again. It's been so long.
Likewise, man. Well, I'll connect with you soon.
All righty.
Peace.
Peace.